Okay, good morning. Still morning, right? Yeah. Good morning. So my name is Andy Hendrickson. I've got responsibility for the Verizon Cloud Platform, engineering and operations. I'm going to be presenting today with Jason Thompson, who's a lead on the team, development lead on the team. So we are going to go through an evolving, actually, conversation that we've been having for a couple of years. So we're going to evolve our last talk, which was called The Illusion of Infinite Capacity, right? So where we're going to go today with this is introduce some concepts, but we're going to more so talk about where we've evolved from an operational standpoint. Okay, so we're going to talk about how we manage oversubscription in the cloud. We'll dig into a little bit of detail, but we're also going to talk about actually, the workflows we've had to build and some of the tools we've built internally to help us with that. Okay, we're going to go through our oversubscription model, how we deal with this with our tenants. We've got an onboarding overview that we're going to go through as well. And basically, there's multiple viewpoints, but the most important to us in part of this conversation is the customer viewpoint and the operations viewpoint. Okay, so we're going to talk about how we deal with live status, storage performance, some bots that we're using, right? Jason's got a neat example for comparatively dealing with oversubscription with the airlines industry, so we'll talk about that. And we're going to talk about some analytics. Hopefully, we'll have time at the end for some questions and answers as well, if I manage the time appropriately. Okay, so let's kick right in. So what is Verizon Cloud Platform? So it's a private cloud. It's an infrastructure that is powered by Openstack. Okay, we've chosen that as our VIM, right? It is basically a federation, right? So we've got multiple VIMs across the globe. It is built for NFV, right? It is built for orchestration, OSS, BSS, right? Our tenants are variant in the sense that they're coming aboard, as they're evolving their applications to be more cloud friendly. Okay, that's an adaptation that we've dealt with over the past year and a half or so since we've been talking with the organization, right? So we've got about 80 regions that we're rolling in production today. A lot of compute hosts, right? A lot of projects, a lot of unique projects, and a lot of active VMs, right? Some of our team are actually working on active VMs right now that should be working, right? In production, right? So what do we look like across the globe? We are spread throughout the states with our core platform, and then we've got a number of international sites as well, supporting workload there, okay? So we've evolved a lot over the past year and a half, okay? Let's dig in a little bit and jump right in on some of the oversubscription stuff. So I'm going to turn it over to Jason for a couple minutes.
All right.
I'll let you get in the middle.
Okay. And to answer the question, to work for VCP, you do have to have a beard and wear black. It's required. Anyway, so I think the core of the illusion of infinite capacity is oversubscription. And I think that we're still kind of in the infancy of oversubscription. A lot of people just kind of go with a standard 16 to 1, 3 to 1, something. And they're not really, letting Nova schedule. Let's let it take care of it, and we're not going to worry about that because we're worried about other things. But I think it's getting to a point where it's becoming important. When you get into 50,000 cores, 100,000 cores, and more, it becomes a big deal. And I wanted to show a good example of that is the airlines. A good and bad example. Some people here will tell you it's a bad example. But if you look at the airlines, when they started out, making oversubscription. I actually used to work for American Airlines a long time ago. They cared about a couple things, right? They cared about the day and time of the flight, the weather, the location, holidays. It was kind of important because they wanted to, still fill the plane and make money, but not make customers upset. They still try not to make us upset. But they realized this wasn't good enough, so they added a few more things. They added in purchase time. They realized that customers that purchased 3 months ago are more likely to cancel than the guy that purchased yesterday. So the algorithm got bigger and bigger and bigger, and the government plays a big part in the oversubscription, because they get their money from it as well. Rumors of wars, actually, where you're flying over changes oversubscription. It's kind of weird. Competitors, what they're doing, also plays a part in that. They use a really complex algorithm, and they're down to for every one customer, every 100,000 customers that buy a seat, only one is kicked off with oversubscription. and overbooking. And that's a 0.00007% failure, and they're fine with that. Now, I tend to think that's boastful, because I've been kicked off a flight here and there, but their algorithm is extremely complex. What we're dealing with isn't just seats, though. We're dealing with a person that can sit in multiple seats across multiple planes, across multiple locations. And it's a whole different ballgame. All the stuff we have to deal with for the cloud, it's way more. There's way more things. And if you look at the current, we're not really using an algorithm in general. In general, people aren't using an algorithm for oversubscription. But we have people demanding, we're dealing with virtual bare metal. We're dealing with customers that say they need 8,000 CPUs for an application that they haven't finished yet. So you can't just go with 16 to 1 or 3 to 1 or whatever you're working with. And even though it's way more complex, the algorithm there is no algorithm. So we end up with fragmentation. It reminds me of a hard drive. I don't know if you've ever remember back in the days we'd had to get an optimizer for our hard drive because it was all messed up. Well, we're seeing that now with the cloud. We're seeing across multiple regions. Nova Scheduler and some of the other tools do great at starting us initially, but then customers get noisy, or we have holes here and we can't fit this perfect customer. So what do? So we started gathering in massive amounts of data and beginning to analyze it and tracking all the aspects of OpenStack network usage, customer usage over time. And Andy's going to show you a little bit of some of the tools we're using for that, some of the analytics we get deep into. And we're working to migrate noisy customers, smaller tenants, and be able to smart migrate automatically. A lot of people are doing this manually right now if you're doing anything at all. And some people don't care about that. But basically, it's like playing 3D Tetris. We're trying to fit people and use up every available piece and still make customers happy. It isn't just about providing customers what they need when they need it, but it's also about cutting costs and automating something that, if it's done at all right now, it's purely a manual process. We're not there yet. We still have a lot to do in this area. But if we want to work it, we have to fix the oversubscription in its current form. Andy's going to show you some tools that we use to manage the capacity in oversubscription right now.
Yeah, hit next. So one of the ways that we are able to help manage through this, because of the different types of applications coming in, we literally have to have multiple ways that we model the CPU, right? So there's people that are involved in the onboarding process, right? When applications are coming in, we have to actually, denote up front, right? Whether it's going to be an oversubscribed, we call our standard model, whether it's going to be one-to-one pinned or one-to-one not pinned, right? In terms of the computes themselves, right? Now, to the tenants or our partners coming in, they shouldn't really have to care, so to say. That's that illusion of infinite capacity, right? But they do, right? Because there is not an infinite amount of capacity coming in. So it's not just a technical challenge, right? It's actually an organizational challenge at onboarding time to actually figure out how to place the different applications across our infrastructure. Some tools that we have to do this, right? Okay, so once they're coming in, well, we can use host ags, right, to actually organize. So the operations team can organize things and they can figure out where things need to go without direct contact with our partners and tenants themselves coming through the process. And we can see and report back on what things are fitting into those. But these charts that you're seeing here as well, so we've got performance is what we call middle of the road. So this is one-to-one, non-oversubscribed with hyper-threading on as a virtual CPU. Standard, today we're using a 3-to-1 oversubscription, right? And we reserve the right to change that as we move forward, right? Some of you will ask me why we chose 3-to-1, because it seemed like a good place to start, and we're reevaluating as we move along, okay? So that's what we call our standard CPU model, right? And then we have a high performance, which is one-to-one, non-oversubscribed virtual CPUs with huge pages available. The breakout in the charts, you can see that we're pretty even between standard and high performance, with a little bit lower with performance for today. We suspect that over time this will change, right? But in working with physical network functions, migrating to the virtual world, right? We can't expect to see this happen right out of the gates, right? So we have to be able to provide a platform, right, to allow them to come on and move, right, as they refactor and rebuild their applications, right? So the customer onboarding view itself, we've had to build some things to tie together. So you're probably trying to figure out, well, what's this architecture he's referring to? Our minimum mapping unit across the Federation is basically a region, right? So we've got many regions across the globe. And we need to be able to tie, all of those regions together from an operational standpoint to be able to see what's happening, what's being deployed, what's being used. Are we approaching, the actual oversubscription, right, that we've planned for? Can we plan for that? So the teams have some tools, right? So we've built some APIs and some things to help us with that. So basically, a customer creates a project through a website, which is kind of detracted from the actual infrastructure team. There's many processes that occur, right? And then that information flows downstream to us, okay? And from some of our suppliers as well. So in the middle here, we see some screens that we've got where we're gathering requirements, okay? We're gathering information about the applications or what they think they need coming in. Now, after that is all completed, that screen on the left that says Platform Analytics, we're constantly looking to see where's the quota, right, that has been reserved versus the actual usage, okay? So that's another evolutionary, issue for us is people are used in the physical world to having an absolute amount of capacity that's available all the time, right? AKA the quota, right? Now, over time, we can actually see, because it's a private cloud, we can see what's actually being used. So the ability to adjust and move things around is absolute to us. It's extremely necessary, and the ops teams are always looking at this, okay? Next. Okay, so this screen on my right and your left, this is the result of actually monitoring and looking at all of the different regions across the Federation, right? Again, so we've created some APIs and some surfaces where we can tie together all of the OpenStack information in one place, okay, and look at it. So we've got live operational status coming across. In the past, I've talked about this service status and site status API that we've built to do that. That's what this is using. Because we have that, and because we have the single surface, we've actually got some meters set up that actually look at the infrastructure all the time, right? So it's looking at provisioned resources as well as the hardware, right? So the meters themselves allow us to, basically aggregate information and look at real-time capacity and utilization anytime we want to, right? So that's what that middle screen is showing us. So our operations staff can actually go in and look at the capacity, right, in real time, and they do this all the time. These screens also manifest themselves on big screens in the NOC and places like that for operational awareness. All the way on the right-hand side is basically the result of real-time capacity and metrics that we're gathering with some bots that are rolling across the Federation as well.
Over 400.
Yeah, about 400 things, right, that are actually going off and testing the performance and looking at our storage and reporting back, right? So we also like to think that this information that we're providing that the operations team needs, right, we also like to think that in the future the applications will be able to leverage this information as well, right? So it's kind of being able to benefit, the application tier for orchestration and things like that. They can actually make decisions based upon real-time information, okay? We call them bench bots, right? So this is that transparency I'm referring to. They're not gonna go away, right? They're probably going to increase in velocity and in scope. Now, again, the tunable for how often we run these things is gonna vary by the bot, right? We don't want to interfere with the performance in the potential capacity available for our tenants and our partners as well, right? So that's a tunable that I think we're always going to have, okay? So the middle screen that you see here is the actual output from our throughput tests, okay? It reads and writes. This has also become invaluable for us as an operations team to be able to go back and do post-analysis on outages, right? So not only are we able to utilize the information in real time from the application logs and things like that, but it almost acts as a third-party resource for us, right? When we're trying to validate what actually happened in terms of building an RCA, okay? Again, this is not tooling that's necessarily provided with OpenStack. We leverage the OpenStack services to do this in some cases, okay? How do we do it? It depends. The storage test is using VDBench, right? But for CPU tests or for other tests, network tests, we use other things, right? So it's pulling and leveraging information from across the infrastructure to actually do this, okay? So along the steel thread of operational view, right? You can go next. How do we allow the integration? How does the integration occur from that application tier? So you're looking at on the screen, on the left-hand side, you're looking at the output of basically a request into the site status and service status API where we enumerate the health of services, right? Back out.
This has evolved greatly over the past, even like month. It evolves every month. We're changing this and evolving it.
Yes, that's correct. And as we move forward and further into actually doing, having the promise of true orchestration unfold, orchestration is able to come into one place and actually pull this information and make decisions about it as well, right? So basically, this is in plain English. This is where I'm giving the applications as well as the operations teams that enumerated value for the health of, say, compute, storage, network, the metering platform itself, other things like that. Okay. That document, the Swagger output on the left is just an example of that API output and how folks are using it for service status itself. Okay. Again, along the thread of evolving what we've been talking about, right, and what we'd like to see come forth through the community, right, is this increased, I don't know if I should call it reliance, but I guess it's a reliance. I mean, we've certainly discovered that our minimum mapping unit for attaining information and then describing or redescribing or reconstructing events on the platform itself, the UUID is super important, right? So this is basically the way we're able to tie things back together from the OpenStack side across with the operational tools to be able to make operational decisions and report back out. So from the foundation perspective, from OpenStack perspective, like keeping the grammar and the use of UUIDs, consistent with releases, that's nicely put, right?
Yes.
Like, do you need dashes or not, and things like that, is extremely important to us, and it's extremely important to our applications. I do want to really, really, really emphasize that is part of our journey here, right, is the information that we have for operations is almost as important or more important to the application teams or tenant operation teams that are actually rolling on top of this platform. So they need to be able to grab this information as much as we do and do something with it, okay? So what you see here is just a graphic sort of describing that UUID is that minimum mapping unit tying everything together, and it allows us to do really neat things with other operational tools. So we have some chat ops stuff that we do, regarding actually a fairly small operations team that has to support 24/7, 365 around the globe. For example, just in a Slack channel, I mean, we can just put in a UUID and it returns to us all of the resources that are tied to that particular UUID, right? So this is really important, right? So for security events, for performance events, just for general contact information, if there's something going on with a particular compute node that's affecting multiple tenants, again, in the oversubscribed and multi-tenant environment we have, I need to be able to immediately notify and contact the right people, right? The operators need to be able to do that, okay? Okay, UUID. Platform operations view. We are constantly looking at what's happening and what's going on. So what you're looking at here is some more screen grabs of some web properties that we have that roll these, basically roll this continued information together. In the past, we've done some talks talking purely about metering. Metering is part of this, but it's also other information coming in about those services as well. So we can, basically by the number tell exactly what's going on all the time. Also, as a business, as we evolve, it's necessary to be able to report back out the validity of what we're doing, right? In terms of bringing everything together into a single infrastructure platform. So this information is leveraged as much by teams external to operations as it is by operations. Right.
Yeah, this comes in from multiple areas. Like it's our metering, it's our service status, and we're gathering metrics from 6 or 7 different areas to get this.
Yeah. And I don't really see that changing.
No. And this is where I'm talking about some of the stuff. We're using part of this to make our migration and our oversubscription smarter.
So let's talk a little bit, about a sample deployment, right? We're making a little bit of a leap here, but what we've needed to do is to be able to create reference ways to deploy, right? And reference ways to better leverage the information that's coming off of the platform. So jumping out of the conversation purely about planning, and adjusting the infrastructure and where tenants are sitting, well, in the future, being more malleable is important. Right? So being able to rapidly move your workload around without being tied to IP addresses, tied to particular regions, tied to actual compute hosts. Right? So this reference architecture is simply, actually, Jason, you could talk about it better than me, but this is sort of how the team deploys all of the microservices that support all of these different tools that I've been talking about for the past 15 minutes, right?
Yeah, I mean, we're using, we're trying to leverage a lot of open source, right? We're trying to we're gathering analytics using Apache Superset. We're to display it and report it, some of the stuff you saw earlier. We're using Screwdriver for our CRCD and building all this across multiple regions. We're trying to use this as a good example for people that are coming in with these monolithic and they're saying, how do we get to a microservice? So, this is another way of showing that. And this is exactly how we're currently doing all the monitoring. We're absorbing all of that metrics we talked about. It's easy to gather data, but if you can't show it, it's worthless, right? And we're gathering all sorts of data. Sometimes at first we'd realize we were gathering, almost petabytes of data at some point, and we didn't know how to absorb it. So we're trying to take this and give you a view of what we're supposed to be seeing, and so we can do something with it from an operations and other aspects.
So let me bring it back to something we mentioned earlier. So the way that we support this internally, this information now upstreaming itself back to our planning community to help them plan future architectures for the change, right? So we have a feedback loop that's actually real now, right? Based on actual empirical data, right? Coming off the platform itself. As we move more, towards, I'm going to get made fun of for saying cloud native, right? Kind of. As we move towards more cloud-native deployment styles for these applications, right, it is going to be important that the ability to move information out of the application and into something that's visible, right, is part of the way that they're architecting the software itself, right? So being able to bus information out, as part of the way the application works, I think is part of the best practices that we want to show, right, and have people leverage moving forward, okay? So let's go with the next one. Another way that this manifests itself is an overall arching view, geographic view of the actual implementations themselves. So here you see a map with alarms coming off of our OA&M platforms, right? Being bundled and so that the operators can quickly see in what region how many particular criticals or non-criticals there are going on at any one given time. Prior to building the sort of centralized approach for doing the fault stuff, it's very difficult to kind of figure out the status across all these different regions, right? We would have operators that had multiple screens open, right, with multiple instances of either Horizon or just the CLI itself, right? This allows us to very quickly look and see there's an issue going on right now in the, in the Northeast.
Yeah, and when there's a critical, it's very annoying. So
you're just proud of that because you wrote the code, right?
I figure they'll fix it faster if it annoys them really bad.
What he's referring to is when there's a critical, the map actually blinks faster and goes more red. He's proud of that, right? And it is annoying. So it makes the operators want to go tag it. So, and do something with it. Okay, so far, I mean, we've basically been talking about things that we've built to fill gaps in the way that we're operating the platform and supporting it. But the steel thread here is that information coming back across to allow us to plan better, right, and to allow us to move workload around, I think is the next talk we're going to be able to have, next year, right? We're able to actually move things in real time without humans having to get extremely involved. I don't see, us not being able to be involved entirely for many years, right? But we are moving we're moving the needle, right? This is a significant evolution over where we were a year ago in terms of limiting the amount of touch, right, and amount of time it takes to get things orchestrated and built.
Yeah, step one was just to be able to notify our ops people so they can deal with it manually. But that's where we're getting is where we can say, hey, there's a problem here, or there's going to be a problem, and you need to fix it. But obviously, yeah, we want to get to a point where it takes care of itself. We got a long ways to go, but we're getting somewhere with it.
That's cool.
Are you saying based on alarms, you would move things?
Potentially,
Okay.
yeah. Or let me answer that in two ways,
Yeah.
right? So I don't know if everybody heard, but his question was, based on alarms, we would move things, right? Remember the two viewpoints that I mentioned when I started. There's the platform viewpoint, and then there's the application viewpoint. So my answer was yes, but that broad sweeping yes is actually for both of those viewpoints, right? So I believe that if I see something, the tenant should be able to see it as well, right? And they should be able to make a decision about moving their stuff, although we may have to do it for them, right, underneath, if it's a really bad failure and they don't have any redundancy in the application layer. But yes, sure. What do we have left?
The other talks.
Okay. So we'll take questions after that. Go to the next one. Back up. So there's a couple other talks this week, tomorrow actually, that the team is doing to dive in a little bit further, right? So if I could see the screen, let's see. Yeah, so Amrith and James are talking tomorrow, 4:40. And Amrith and Fred are talking tomorrow at 11, where they're going to dig in a little bit more on some of the topics that I've described here this morning. So for now, let's take some questions and see where the conversation goes, right, if that's okay. There's this mic thing. I don't know if I'm supposed to ask you to come up here. I could throw the, oh, I can't throw the mic to him. Sorry, I won't touch your mic.
Following protocol here. With regards to UUIDs,
Yeah.
how do you guys handle when, say, somebody deletes a cinder volume? Do you retain that UUID for a length of time, or when do they expire?
It's a really good question. Right now, we're keeping them in perpetuity, to be honest. Yeah, we need to figure out what the expiration is. We haven't had to make a policy decision on that yet, but it's a good question. Yeah, and I mean, there's also the, I don't know if it's probability, but there's a probability having multiple VIMs that we have a problem, right? The probability is low and odd, right? But it's there. So we have to, that's a really good point. We need to solve for that in the next 6 to 8 months.
Yeah, and we're working on, like what he's talking about, we're working on a million things, but one of them is getting like a hardware and software historical.
Yeah, so right now it's forever until we decide, which is good for you guys, right? Storage guy. Any other questions? Right, I usually do that. I wimped out this year.
Yeah, we had some issues with the network here between us and them.
It was all supposed to be live today, and then the VPN stuff scared me. So
We normally only do live.
who said that anyway? Bowen? That was Bowen. Sure.
So from your first slide, I was just looking at the different oversubscription models you had here for your CP model definition. Have you evaluated some of the other models that are available inside of Linux and KVM? Like, for example, KSM allows for memory dedupe. That's a powerful memory oversubscription technique. I'm just curious as to what other types, other than the 3 that you listed here, you had looked at.
So the 3 that we have there are meeting the needs of what we have today, right? So I think there's a lot of options on the table that the planning organizations are looking through, right? So the answer is yes, right? We can evolve as we need to.
Okay, and do you have similar oversubscription mechanisms or strategies for what you plan doing for network and storage as well?
Sure. Yeah, we've got, so again, this is part of the planning process itself. Okay. Nothing we're able to kind of go through as it's been productized at this point.
Okay.
But sure.
But yeah, we are recording like all network performance and traffic and using that as well as analytics. Not just in the OpenStack, but outside of OpenStack as well.
Okay, awesome. Thank you.
Yep, sure.
And
Yes.
I wanted to mention, everything we're doing for storage right now is using thin provisioning models, so we're already effectively oversubscribed on storage.
Yeah. So our planning team's like right here, so they're coaching me on how to answer that question for you.
They're trying to keep us honest.
Yeah, I mean, actually, if you want to grab a mic, Stuart, and
Absolutely not.
Okay.
I think that was a disconnect we had for for a time anyway, was the disconnect between planning and, now it's kind of, we're sending in a lot of it, like you just said at the very end there.
Well, now that stuff's getting real, now that there's production workload, there's real feedback that's coming back through our planning process.
Yeah, in case
which
somebody
we've-
didn't know, this is all in production. This is all, we got real people. This isn't just a prototype.
So, any other questions? So we're going to wrap up a couple minutes early. You guys are very kind. Finished on time. Thanks.